Hi there, I'm Mrs. Embry, and this is a video for teachers explaining some background and helpful tips for conducting the comparison of fuel values investigation in your classroom. The first thing I want to do is explain how you might set up the apparatus for determining fuel value. You'll need to have some uh, aluminum cans with the tab still attached, and you'll need a ring stand and a ring clamp. You'll need a thermometer or temperature probe, and you'll need a graduated cylinder to measure the water that goes in the can. So you start with the can and the tab vertical so that it's sticking up from the top of the can. And you'll put that under the ring clamp on a ring stand and use a glass stirring rod on top of the ring clamp that goes through the tab to suspend the can from the ring clamp. In the can, you want to have 300 milliliters of water that will be heated up when you burn your fuel sources. You need a thermometer or a temperature probe so that it is suspended in the can. You don't want the probe or the thermometer to rest on the bottom of the can. So you want to suspend that so it's measuring the temperature of the center of that mass of water. So you will need support for your thermometer or temperature probe. And that can be students that hold the thermometer or use the thermometer to measure at the beginning and the end of the investigation. You don't need data, you don't need temperature data throughout the entire combustion process. You need the initial temperature of the water and the final temperature of the water. So you can just measure the temperature at those 2 points. When you adjust the height of the can, you want to make sure that your fuel source is burning so that it is close to the bottom of the can. The further away it is, the less of that energy you're able to capture and use to heat up the water. So you don't want a lot of distance between your fuel source and the can with water. If you have students doing this investigation in your classroom, you want to make sure that they're following safe lab procedures. You will have open flames. You want to make sure that there is ventilation in your room. Sometimes the combustible fuels will have volatile elements that need to be ventilated. You'll want students and yourself to wear safety goggles, have long hair tied back, closed-toed shoes, the standard safety procedures for your classroom. The spirit alcohol burners that are used in this investigation are designed for specific types of fuel. So you don't want to test fuels like gasoline or diesel fuel. That would not be safe in a classroom environment. On the website, you will have access to a lab report for students and a slideshow that explains a pre-lab discussion and a post-lab data analysis discussion. There's also an answer key for this lab investigation. There's a form that you will fill out for access to that answer key so that we can make sure that your teachers and that you're going to use that answer key for this investigation. You'll also have access through that form for editable versions of this lab report and the slideshow so that you can add your personal touches or take out things that don't apply to your class. So if you want access to those, then you can get there through the form on the website. This investigation might be useful if you're teaching a chemistry class, or it might also be interesting for an environmental science class. Some possible extensions that you could pull in with this investigation are looking at the environmental impacts of the fuel sources. There's a particularly striking difference in the amount of soot that's produced by the different fuel sources. By looking at the outside of the cans after they've been burned, there's a dramatic difference in the amount of soot or carbon particulates that are produced by different fuel sources. So that could lead to a discussion of air pollution. You could extend the discussion into renewable or non-renewable fuel sources. You could discuss extraction or processing or transportation of fuel sources. You could talk about the waste that's produced or the potential for oil spills in transporting fossil fuels, or the use of food crops such as corn to produce biofuels like ethanol. You could use this investigation in a discussion of organic chemistry and compare the different types of alcohol-based fuels in terms of their fuel value. Another interesting extension could be a discussion of the potential sources of error in the lab. Some heat is lost to the surroundings. Not all of the heat is used to heat up the water in the can. So that might be a discussion that's valuable for students to have. You could also talk about precision or accuracy or lab skills that students are learning with this investigation. One way that I like to end an experiment is through a claim, evidence, and reasoning conclusion that students can reflect on the investigation that they've done and express the things that they found out in the investigation by making a claim. In this case, they would make a claim about the fuel value of different fuel sources. The claim should directly relate to the question that they're investigating, which in this case is about the fuel value of different fuel sources. So based on their experiences, students make a claim, a statement of something that they have discovered or confirmed. The next step in the claim, evidence, reasoning conclusion is the evidence. So this is where they will present their graph or summarize the results or use specific data that they found in the investigation to support their claim. They're making an argument, and by using that evidence, that data to support their claim, they're making it stronger. The final step is the reasoning. A lot of times students will just say, well, look at the evidence and it's obvious. But by putting that reasoning into words, the students are again strengthening their claim. Another part of the reasoning part of the claim, evidence, reasoning conclusion is defining the terms that they use and clarifying the concepts. So by making that reasoning statement, then they're providing evidence to you, the instructor, that they understand what the investigation entailed and what it was about. This is also a place where they could talk about potential sources of error that might weaken their claim, and they can justify the claim that they've made or refute those arguments. So I like to end the conclusion with the claim, evidence, and reasoning because it shows me what students understand and what they learned from this investigation. I hope that this has been helpful, and I hope that it inspires you to investigate fuel values in your classroom.